Welcome to Module 5, Lesson 6, Circle Equations. So the standard equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center of the circle and r is the radius of the circle. The standard equation helps you quickly identify the center and the radius of a circle. So let's take a look at this example. We have the equation here, x minus 3 squared plus y plus 5 squared equals 16. Let's identify the center and the radius. So again, here's your standard form of a circle. And if you notice, right, this is very similar to the vertex form of a quadratic. We have this minus sign here. So that means when we're given the equation of a circle, you want to take the opposite sign when identifying the center, right? This minus sign indicates opposite sign. So, for example, the center here would be 3, -5, okay? So notice how we have minus 3 here, so it's going to be positive 3. And we have plus 5 here, so that's going to be -5. The radius is going to be the square root of 16, which is 4. And just for fun, let's find the diameter because you might be posed with questions like that as well. That would be 2 times 4, which is 8. Please pause this video and work on the Lesson 6, Level 1 problems in the workbook. In Level 2, you're going to have to remember some geometric formulas in order to answer some of these multi-step problems. So you need the distance formula for sure, and you may or may not need the midpoint formula depending on what route you want to take to problem solve, but you definitely need the distance formula. So is the point in the circle? This is a typical type of question that you'll get on the SAT. The equation of a circle is x plus 2 squared plus y minus 1 squared equals 25. Does the point 1, 3 lie inside, on, or outside the circle? So first, let's identify our center and our radius. Our center is -2, +1. And the radius is the square root of 25, which is 5. We're going to use the distance formula to calculate the distance between the center and the point that the question is asking about, right? So your distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to use the point 1, 3 and label that x1, y1, and I'll take the point -2, 1, and we'll use that as x2, y2. So substituting into the distance formula, we get the square root of 1 minus -2 squared plus 3 minus 1 squared. Simplifying, you get the square root of 1 plus 2 squared plus 3 minus 1 squared, which is equal to the square root of 3 squared plus 2 squared, which simplifies to the square root of 9 plus 4, which is equal to the square root of 13. Now, the square root of 13 is not a perfect square, but it's approximately 3.6. Now, what do we do with this information in order to answer the question? Well, since 3.6 is less than the length of the radius, then the point lies inside of the circle, right? Because the distance between the center and the given point is less than the distance between the center and the edge of the circle, right? Because that would be the radius. So the point has to be inside the circle. Now let's write the equation given the center and a point. So find the equation of a circle with the center -4, 5 that passes through the point 1, 5. Okay, so first let's find the radius, right? So we have the center. That's part of what we need to write the equation, but now we need the radius. So in order to find the radius, we will find the distance between the center and the point that they give us. So we'll use the distance formula, substituting in, right? I just used the point 1, 5 as our x1, y1, and -4, 5 as our x2, y2. So substituting into the formula, we get that the radius is 5. So now let's just take our center, -4, 5, and our radius 5, and substitute into our standard form of a circle. And we get x plus 4 squared plus y minus 5 squared equals 5 squared. And just simplifying that by squaring 5, we get x plus 4 squared plus y minus 5 squared equals 25. Please pause this video and work on the Lesson 6, Level 2 problems in the workbook. Moving on to Level 3. In Level 3, you're going to have to recall a skill that we learned when we worked on solving quadratics, right? We learned a method of solving quadratics called completing the square. So if you don't remember how to complete the square, please go back to Module 3, Lesson 7, Level 3. Review that video, review your notes, review your problems, because you will need to complete the square in this level, because we will be using completing the square to rearrange equations of circles that are not in standard form to the standard form. So I hope you brushed up on the completing the square method, because now we're going to use it to convert to standard form. So let's rewrite the equation in standard form and identify the center and the radius. We have this equation here, x squared plus y squared minus 6x plus 4y minus 3 equals 0. So the first thing we want to do is regroup the x and y terms together and move that constant, that -3, to the other side of the equal sign by using inverse operations. So we're going to group our x terms together. So we have x squared minus 6x, plus we'll group our y terms together, y squared plus 4y equals 3. So now we're going to complete the square for x and y, right? So just taking a look at the x squared minus 6x, right? The first thing that we're going to do is add b over 2 squared to both sides. So in this case, it's 9, right? And if you look at your group of y terms, y squared plus 4y, right? We're going to add that b over 2 squared to the end of this, right? So b over 2 squared, we get plus 4. And we're going to add both 9 and 4 to the other side of the equal sign, just like we would do when we were solving quadratics. Now we just have two constants to add to the other side of the equal sign, because we're completing the square for x and completing the square for y. Now we'll rewrite this as perfect squares to get the final equation in standard form, right? So we get x minus 3 squared plus y plus 2 squared equals 16, right? That's just the next step in completing the square. So now we can identify the center as +3, -2, and our radius is the square root of 16, which is 4. Please pause this video and work on the Lesson 6, Level 3 problems in the workbook. Once you're finished with the problems in the workbook, you've reached the end of Module 5, and you've reached the end of all 5 modules. So congratulations on completing all 5 modules of this course. I wish you nothing but the best of luck on the digital SAT. You guys are going to kill it. I know it. Feel free to go back and rewatch any of these videos as many times as you need to and keep on practicing, right? Make sure you've completed all the problems in the workbook. Don't forget to use your reference table. Don't forget to use the 3 reads protocol, and make sure that you're extremely proficient and fluent in using the graphing calculator and Desmos, because those 2 tools will really, really help you succeed on the SAT. Best of luck to you.